guys. So today we are facing the subject math GRE 9367 and the final question number 66. Oh, by the way, so usually in a test, the final 6 question usually is difficult, especially to the in the final question. So usually in the test, if you do not have time, then you just randomly guess the answer. I mean, if you have time, then you can clearly think this problem. Okay, so also remember that in a test case, then usually you can. So if there are integer involved in the question, then you should try the small case and do the guess, and try to get a feeling of how things going. So let it be a positive integer, and I choose, and from 1 to 2n, I choose n plus 1 number. And where the xi is a is a what? Oh, it's as an integer, which the following must be true. So this is basically from 1 to n, and I randomly pick n plus 1 integer, and ask about which one following must be true. So this kind of problem is usually called combinatorics, and somehow related to number theory. So usually this type of problem has many open questions. Okay, so the first one there is this xn is the square of an integer. Actually, I don't know which is this is right or not. But how about I try a small case? So how about n equals to 2? So I have to take 3 numbers from 1 to 4. Right, so I have to take 1 to 3, 2, 3, 4. Yeah, so and I don't have other way to take it. But there has some square 1 over 4. So remember, this cannot prove the first one. How about I try n equal to 3? So n equal to 3, I have 1, 2, 3, 4, 5, 6, and I have to take 4 numbers. And can I take all of them? None of them is square. Yeah, I can take 2, 3, 5, 6. So if I take these 4, then none of them is square. So the answer is the first one statement is false. Is false. Okay, so let's skip the second and see the number 3. There is this Si, which is prime. Okay, this looks very difficult. Okay, because somehow I mean, it looks like this is some open problem that you take 2n number and then you take any n plus 1. Maybe some of them must be prime. So when I think in first way, I think I that idea that how should I disprove it, or I try to disprove it. So one way is like from 1 to 2n, I take only so from 1 to 2n except for 2, I take only even number. So it will take n minus 1 number. So it will take n minus 1 number, right? Because from 1 to 2n you have n even numbers, but you don't want to take 2 because 2 is prime. So I can only take n minus 1 number. So to disprove this, I can take another other 2 numbers, which is odd but not prime. So if this fact is correct, if this procedure is correct, then I can disprove this. So let me show you where this is possible. So for example, like n equals to I remember I tried okay, so I can try n equals to 8. So when n equals 8, I have 1 to 16. Okay, so I need to take 9 numbers. Take 9 of them, and none of them is prime. None of them is prime. So basically, I can take the I first take not two. I first take all the even number. Right, definitely these are not prime number. Right, so I take 7 of them, and the rest I just need to take 2 of them, which is not the prime. So I can take 9 and 15. So 9 of them is not prime. 9 of them are none of them are not prime. Okay. So the number 3 is false. Okay, basically so the second method is that so there's the fact that there exist 25 primes smaller than 100. So if you take n equals to 50, then you can definitely choose 20. You can definitely choose 51 numbers from 1 to 100, and then none of them are prime. So basically, I just show a small extreme case, but if you know this fact, then you can solve this very quickly. So 1 and 3 are false. So the only case is number 2. So the answer is B. The answer is B. Okay, but how do we prove B is correct? So then let's see the B. So the number 2 says that there is an integer I such that xi plus 1 equal to xi plus 1. Okay, x. So xi plus 1 equal to xi plus 1. Nice. There's no. So when I do English pronunciation, then I cannot distinguish them. Okay. Exist. And the reason is that suppose not, then x2 must be larger or equal to x1 plus 2, and x3 larger than x2 plus 2, xn plus 1 or larger than xn plus 2. Then this will give a contradiction, right? Because x1 is larger or greater than greater than 1. So basically, this tells you that x2 must be greater or equal to 3, x3 must be greater than or equal to 5. The xn plus 1 must be greater or equal to 2n. Because this is 1, right? So this must be larger than 3, this must be larger than 5, and then this must be larger than 2n plus 2 minus 1, right? Because this is 3, so this is 5, this is 2, this is 3, so basically this is larger than 2n plus 1. But unfortunately, what we need is xn plus 1 smaller than 2n. So these two makes a contradiction, right? Because xn plus 1 is too large, that it already exceeds the bound. So that means our assumption is false, right? So the answer is the second statement. So we choose B. we choose B. Okay, congratulations, we solved it. And I already did 4 of Math GRE subject exam, and I will do the 5th. Then we will go to solve the physics, and I will go back. I will go to create some interesting content which I like. So hope this video help you guys, and I will see you in the next video.